So welcome everybody to my channel. On my previous video, I actually had a 30 minutes of a long video which showed the code part and simulation part. Today in our video, we are only going to focus on the simulation part as it is too long and many people can't understand from the start to the end. We are going to see what this project is mainly about and what it does. So especially our project is of taking an electric vehicle and inducing an ADAS module and fault detection. So first of all, in picsimlab we have shown that this is the acceleration pedal, this is the brake pedal which you are going to control from 0 to 3.30 using the formula of 12-bit SOC pedal and temperature, and this is the virtual terminal, and this is the front ultrasonic sensor ranging from 0 to 400, left ultrasonic sensor 0 to 400, and the right ultrasonic sensor from 0 to 400. And these are the LEDs, like red one for the front collision, blue one for the left blind spot, red one for the green one for the right blind spot, and yellow one for the fault detection. So first of all, and next one we are going to see about the virtual terminal. So here it produces speed, SOC, torque, temperature, right, distance, acceleration, brake, front, left, right, time to collision, collision warning, blind spot detection, alarm, and fault any. So now you will see that speed is 120.9 kilometer. In our code we have set if the speed is more than 120, it should automatically raise an advisory alarm. Here it will not be shown, but you can see it in the our dashboard. See, it is 121 kilometer and it shows alarm advisory. So and you can see that this is the torque of 150, an acceleration of 100%, brake of 0%, motor temperature of 34.2, alarm as alarm advisory, and this is the speed of 121, and this is the battery level and how many range it can go, and this is what mode it is, and speed history from 0 to till now what speed we are traveling, and this is the ADAS bird view. So if it goes less than 120, automatically this alarm advisory will be removed. So let us wait till that time by setting the brake pedal to the high and reducing the acceleration pedal. Yeah, now it become 119 kilometer per hour after waiting, and you can see here the battery has been 98.9, it has been increased. This is a concept of regenerative braking. As we applied brake, the torque becomes negative of minus 56 and a brake of full 100%, and you can see that no alarm has been blinking here. So now let us check about the forward collision. So in forward collision, if the distance of the ultrasonic sensor goes less than 200 km, that is 118, both this front collision and the fault detection automatically gets on. And in the dashboard, you will get a critical alarm and a fault of 0x04, and no further torque has been applied here. So vehicle cannot be accelerated from that speed, like from 119 it cannot accelerate, it automatically reduces its speed. And you can see that if I reduce more and more, there will be more critical alarms, like it will blink more faster. Yeah, see how faster it is blinking. And if I increase it to more than 200, it will automatically remove that alarm. Yeah, see, you can see that the alarm has been removed, and no alarm has been given, and the torque has been applied because of that brake. So now let us see the left and the right blind spot. So in the left blind spot, it should be greater than 20 km per hour speed, and the distance should be less than 30. So if it is less than 30, automatically it produces a LED blink, like left blind spot here, and in our dashboard it just gives an advisory alarm without reducing the speed, like blind spot left 25 centimeter. And if I increase it from more than 30 centimeter, automatically that blind spot will be gone. Yeah, now you see that blind spot is gone, and here you see critical alarm has been removed. Now for the right blind spot, same like that, greater than 20 kilometer per hour speed, and the distance should be less than 30 centimeter. It produces a green LED. So this is the right blind spot, and in here it will give an advisory alarm 11 centimeter blind spot right. You can see this in the dashboard, and no torque is been reduced, or it is sent to 0. And if you want to remove that alarm, it should go greater than 30 centimeter. Automatically that alarm is been removed, and here you can see that alarm is equal to none. And here now for temperature, if the temperature is more than 90, automatically it produces a yellow color fault detection. And here you can see no further torque is been added, is 90.6. And if we reduce it slightly less than slightly less than 90.6, automatically the fault detection is been removed, and the 0 cross 01 and the motor temperature becomes normal, and the torque is now being implemented to the vehicle. For the SOC, we did not give the SOC in between value, because at start only it takes the SOC, and after that we did not initialize what, like for acceleration, brake, temperature, we have called that parameters and we have converted it to 0 to 100. We did not done for SOC. So for SOC we should give it to 0, and then click on the reset button. If you click on the reset button, automatically that fault detection is being shown as you see in the screen. And here you can see fault 0 cross 02, and no torque has been applied, and battery percentage is 0.0. And here if you increase also, no reflection will be given, as we did not read from that point of view time. So if you go greater than 0, and if you click on the reset button, automatically that fault detection is been gone, and it automatically the dashboard goes to a full 100%, because once you off the vehicle you should charge to full 100%, then only the vehicle starts to go. So this is the full 100%, and you can see the range here. So this is my simulation part of my EV ADAS module. So thank you all for patiently watching my video. So please tell what suggestions in comment and like this video. Thank you.